This lesson is going to go over notes on empirical and molecular formula. So first of all, let's define both of them. Empirical formula is an estimation of a chemical formula. It's not the exact chemical formula, while the molecular formula is the exact chemical formula. However, in order to write out successfully your molecular formula, you need to solve your empirical formula first. So I'm writing out the steps of writing out an empirical formula to molecular formula. And in doing so, we're going to use an example in regards to nicotine. Nicotine has a molar mass of 162.1 grams per mole. That's the molar mass given to you by me. The composition of nicotine is 74% carbon, 8.7% hydrogen, and 17.3% nitrogen. The very first step is you've got to solve that empirical formula before we can get to the molecular formula. So I've written out the steps for you. We need to first find the molecular formula, is change the percent to grams. We're assuming that 100% is 100 grams. I'll move this up a little. So by changing all three of those from percent to grams, we have 74%, 8.7%, 17.3%, and now we've changed that to grams. That's step one. If it's already in grams, the step doesn't need to happen. It's already taken care of it. The next step is to convert those grams to moles. If you don't remember how to convert grams to moles, please review the video I made on converting grams to moles, moles to grams. In order to do so, you need your periodic table and calculate your molar mass of each of these elements. And I've done that using dimensional analysis. So I've shown you the steps. Dimensional analysis, you're canceling out the units. When it's next to each other, you're multiplying, and below, you're dividing. The answers of those three are 6.1615 moles. And again, you can use 2 decimal values. You can truncate, or you can use 3 decimal values also. You don't want to use too many. However, you want to make it a little bit more precise. All right, let's move on to step 3. So looking at all of these conversions into moles, you're going to choose, step 3 is choosing the smallest number of moles and dividing by that smallest number of moles. So let me write out that step 3 for you. There we go. We'll move the slides since I pre-wrote these. So dividing by the smallest number of moles. The smallest number of moles was nitrogen's moles. I'll move that up a little. And by dividing that out, you get 1. Now, we'll notice that when we divide them, we get about a whole number. So they are whole numbers. You can round if the answer is, let's say, 4.97, or if it's 6.99 or 7.01. If they are not whole numbers, there is something you need to consider. So I have an example here that we've done together in class. And I'm just going to refer to that example. This is not the example that I'm showing you right now. So you'll notice that these are not whole numbers. If you divide out by the smallest number of moles and you get a decimal value, you need to multiply by a number to get to a whole number. So I've given you some suggestions. If you have a 0.5 decimal value, you can multiply by 2 to get a whole number. When you multiply out, you have to multiply out by both subscripts. So that means that if I multiplied this by 2, which I would to get a whole number of 3, I need to multiply that by 2 as well. If you have decimal values of 0.33 or 0.66, you're going to multiply by 3 to get a whole value. If you multiply by 0.25, or if you have a decimal value of 0.25 or 0.75, you're going to multiply by 4 to get a whole number. So the key is to get a whole number. In this example, we have whole numbers, so that step is not necessary either. So now we can write our formula for empirical, an estimated formula, by using this value and making it a subscript. So it's C5, H7, and N1. You don't have to write the 1, but if you write that, it won't be marked wrong. So we're writing the empirical formula. But the question was actually asking us, we refer back to the question, what is the molecular formula of nicotine with this information? I also gave you the molar mass, and this is going to be now necessary to use to refer back to. So we need to calculate the empirical formula's molar mass by using the periodic table. Again, refer back to the video on calculating molar mass if you don't know how to calculate molar mass. We've done the work for calculating molar mass. Again, at any point during this video, you can pause and write this information down. That I considered step 5 since it's a continuation from writing empirical. And then what you're going to do is step 6 is going to require you to divide the molecular formula molar mass by the empirical molar mass. Empirical formula molar mass, excuse me, tongue twister. So I've got my value from what I've been given in the question. There you go, just a reminder. I'll move this down. Given in the question is 162.1 grams per mole. This is what I calculated for molar mass. These units cancel out, and I get the numerical value of 2. I can take that 2, and my last step for producing my molecular formula is to multiply the whole number to the subscripts of the empirical formula. This, if you remember, the first numbers, 5, 7, and 1, came from the empirical formula. I multiplied by the 2, which I solved from the division problem, and now I get my exact formula for nicotine, C10H14N2.